All right, everybody, we're back with Keith OBrien, and we're live, and we're going to be talking about IPv6. So, Keith, let me bring down the house music a little bit here. All right, and you were talking about why do we need IPv6? Would you?
Yep.
I know you've got some shots you want to show us and stuff.
Sure, yeah. Let's go through a little more meat. Yep. Yeah, let's go through a little more meat on that. Give me a second, and we'll share my desktop here for you, and we'll go full screen. So let's talk a little bit more about why we need this. And this is, something I found in the fifth wave. We're out of IP addresses, right? So, and in some extent today, this is true. At the international level, as I mentioned before break, we are out of IPv4 addresses. So that's really the reason, in short, why we're seeing v6. But there are some other side reasons, right? So we have this depletion of global IPv4 addresses. But one of the other benefits, and this gets a little nitty-gritty and technical, one of the other design constraints that was put in when the engineers were developing IPv6 back in the 90s was that we also wanted to reduce the size or optimize the size of internet routing tables. And that also is going to become a concern that people should be aware of as we start ramping up an IPv6. Obviously, no one is greenfield here, meaning that there are very few people who are going to be able to come into this with a clean slate and build a network from scratch. So most people are going to have to take an existing network that's running IPv4 and transition that to IPv6. One of the side effects of that is that in routers in the internet, we're now going to have to be what we call carrying routes for two protocols as opposed to one. So that does put additional constraints on the core routers and routing protocols. That's something also we have to consider. One of the things I do want to mention, though, since this InfraGard is historically a security organization, and this is one of my areas of focus and something that we're already starting to see, and is security. How is IPv6 going to impact security? And this is a little aside. It's not on the slide here, but one of the things that we need to be aware of as we're deploying IPv6 is that things are going to change. The attack surface is certainly going to change as networks go to IPv6. I'll give you an example. So people involved in information security have probably heard about man-in-the-middle attacks, and there are many ways that can occur in IPv4 networks. And there's this misnomer in IPv6. If you just flip through some basic books on IPv6, and some people incorrectly assume that for whatever reason IPv6 is quote-unquote more secure than IPv4. And in doing this for a couple years now in actual deployments, I'm finding it's really the opposite for two reasons. Number one, since we are deploying a new protocol in new networks, a lot of the implementations of IPv6 haven't really been tested, through the course of time. So we're coming up with new security bugs that haven't been discovered yet, and it's almost a rewind. If you've been in the security industry, like in the late 90s, early 2000s, we had a lot of these network-based attacks like Smurf attacks and broadcast amplification attacks, which we thought have gone away. Well, my prediction is that they are going to come back with a vengeance when we start deploying IPv6 for no other reason that it's a new protocol, new implementation. People are going to make mistakes in that implementation, make mistakes in the designs of their network, all those kinds of things. Another aside on that is things such as man-in-the-middle attacks, which I just mentioned, actually become fundamentally easier, not harder, in IPv6. To give you a little sense of that, in IPv4 we have this protocol called ARP, Address Resolution Protocol, which allows other computers to find one another on a local network. In v6 we have this thing called a Neighbor Discovery Protocol. The protocols themselves facilitate man-in-the-middle attacks, unfortunately, in the sense that if I'm on a v6 network and I'm a bad guy, what I can do is I can actually just tell everyone in the network, hey, you know what? I'm the router on your network. Send all your traffic to me. In the v4 world, you had to do really arcane things like ARP spoofing and ARP cache poisoning and things of that nature, you could argue that those kinds of attacks become fundamentally easier in IPv6, not harder. So my contention is that one of the things that we do have to be aware of as we're moving to this V6 world is certainly security. And hopefully we're going to, we'll certainly follow up on that with InfraGard in the chapter later on in this year. But all right, so back to the need for IPv6. Again, it's really about the addresses and the running out of addresses, but it's not just the fact that we're running out of addresses. It's also compounded by the fact that we are having more and more devices connected to the network, right? So in the last couple of years, we've seen a proliferation of smart devices, smartphones. Everyone has an Android device and an iPhone. As we go to new networks on those with those phones, like 4G networks, many 4G networks, the underlying technology of those networks is IPv6. So that, and luckily enough, and that is, without that, it would have put an additional crunch on IPv4. So just in some of these newer things that are coming out, luckily are already adopting IPv6 because they know better. But if we didn't do that, just the sheer number of devices that are connecting is further exacerbating and accelerating the rate that we're running out of IPv4 addresses. This is a slide that I put together just to give a visual as to where we stand and where the prediction is currently as to when we're running out. So hopefully you can see my arrow here. These are IANA, I mentioned before break, is this international registry that hands them out at a global level. The way I did this graph here, this is the percent probability that these individual registries are going to run out and when. Well, we already know that IANA has run out, so that's 100% probability. It's already happened, and that happened in 2011, as I mentioned before. This one is actually going to be shifting over, if you kind of shift all these over, because it hasn't actually happened yet, but the order that it's going to happen is actually accurate. So the next registry that's predicted to go next or run out next is Asia, as I mentioned, APNIC. After that, we have RIPE, which is Europe. We're probably going to follow shortly after that. Probably the best guess now for North America is if we do nothing, and fortunately we are doing things to preserve and things of that nature. If we did nothing, we would probably run out. We would have run out this summer, but now the projection is early next year, sometime in 2013 is when we'll hand out the last V4 address. And there have been other things that we probably don't have time to go into at the moment, but there have been other things going on in ARIN that they probably never will actually allocate the last V4 address. They have policies already that they put in place that they're going to have kind of an emergency reserve, but it's kind of irrelevant because as a user of these addresses, whether you're working for a company or a provider, you're no longer going to be able to go to them at some point and ask for more addresses. The answer is going to be no, ask for V6. And then on the slide here, you see following North America, we're going to have LACNIC, which is Latin America, South America, and then finally Africa, which is AFNIC after that. So a couple of years after that, the whole world will basically be gone. But luckily, we've all woken up and see this projection, and we're all doing something. Here in the United States, major providers such as Comcast are already aggressively rolling out V6. Comcast is probably one of the most aggressive in their proliferation of IPv6. Have had trials, betas in 2011, and they're certainly pushing that forward within 2012. So certainly in North America, providers are ramping up and offering that as a service to their customers. And, certainly by 2013, the hope is that we'll be in a pretty decent position as far as moving over to IPv6. Now, that's not to say I don't think there's ever going to be a time, at least not in my career, where we're going to kind of shut off the IPv4 internet. What's most likely going to happen, certainly in the shorter term, is that they're both going to be running in parallel. So what that means to you as an end user is that your machine in your house is going to have an IPv4 address and also an IPv6 address, and probably multiple IPv6 addresses.
All right, Keith, that's probably a good place just to stop it for right now.
Okay.
We ran a little over on that segment, but that's just fine. We'll
Okay.
be back to you, everybody, in just a few minutes, and we're continuing with Keith OBrien on IPv6.
Great.